understand SQL structure. Yeah. 8.1, database schema concept. All right. So description of a database. Schema. Yeah. So when you see this term, yeah, the meaning, the special meaning of this one. Description, yeah, actually we can also call it definition of the database. So basically we need to define all the tables, yeah, and also we may need to define some constraints. Yeah. Other than the table definition, you may also need to define constraints. Yeah. You know, and so everything, yeah, including stored procedures. Yeah. So everything you use SQL commands, SQL statements to describe your database. So we treat as the schema part. Yeah. And that's the metadata part, right? Yeah. Metadata. Yeah. That's the metadata part. And another thing is, when we talk about schema, this concept, it does not contain the data part, business data part. Yeah. Only the definition part. Yeah. All right. Specified during database design. Yeah. Not expected to change frequently. But this sentence I like to explain. Because when we look at the database design, whole process, yeah, so you will see in the early stage of the database design, people need to change frequently because at the beginning you do not have good idea. Yeah. At the beginning, you need to understand the project, right? So it takes a lot of time. The database designer people and the business people, they need to communicate, try to understand the business requirements, and the back and forth, meetings, communications. So a lot of things could change. So in that early stage, database structure, definition, design changes frequently. Yeah. Then later, yeah, after several rounds of evolution, yeah, several rounds, then the structure of the database becomes more and more stable. Yeah. Yeah. Then, in the stable situation, then this is correct. You're not expected to change frequently. Yeah. Because every time if you want to change for the stable version, it's a big business decision. Yeah. You need to consider a lot of factors. Yeah. You can change, yeah, so no problem. If you can justify it, if you have some very good reasons, yeah, sometimes it's very important because the business requirements could change. When the business requirements change, that happens frequently, right? Yeah. Then, in order to satisfy certain business requirements, you need to change your database, the structure, the design. Yeah. But in that situation, because it is already in the stable version already, okay, pretty solid, powering the business application, running smoothly. Think about if you want to change your database, you need to consider the impact. Usually the impact could be pretty big. So that's why. So you really need to consider, you need, without, because you don't want to make any damage on your data. The damage on your data, or another thing is damage the user's experience, right? Yeah, because when you change something wrong, your users, your customers immediately experience some problems. Yeah. So that could happen. So in that situation, if you have to do in that way, so you have to do the change, modification, try your best to fix all the possible problems. Yeah. So that is very important. Okay? Very serious issue. Yeah. All right. All right. Then schema construct. Yeah. If we look at it, so what's inside the schema? Yeah. Right. You know, because you need to define different constructs inside your database. Yeah. All right. Entity. Yeah. So here we have the term entity. Describe entity. So in the business, you need to study objects in the business, right? Yeah. For example, our university business. So there are many entity type objects we need to describe in the business. For example, student is an entity, right? Yeah. Student, yeah. One object containing a lot of information we need to store in the database. Course is entity, okay? Yeah, course, yeah. So then, you know, prerequisites, okay? So all these things, entity, object, yeah. All right, that concept. All right. So in the table, a row in a table or a record. Yeah? So each row represents one object in this entity type table. Yeah. So here, table. We use a table to store the information of an entity. Yeah. Yeah. Here, this table, actually, next slide, the table here, there are two types. Yeah. Entity is the first type. Type 1, entity type. And there is type 2. Yeah. Type 2, yeah, actually, recall, in our last class, when I talk about case studies, pre-processing things, the type 2 table we used. Yeah. Type 2 is the relationship type. Relationship type. The next slide, I will explain. Relationship type. So basically, there are these two types of tables we want to describe in business. Yeah. Now this slide, I do not want to expand these two concepts because next slide I need to give you more details. Yeah. All right. Represents a real-world object, such as employee. Yeah. Oh, yeah. Regarding because in this module 3, we focus on the SQL basics. Yeah. So after today's class, I will post the company database. Yeah. I said I need to post before, but I didn't because we didn't use it. Right? In our examples we use, in our regular expressions, yeah, so we use a little bit. Yeah, but here, this time, I need to give you that database script. Yeah. In our homework assignment, first homework assignment, I didn't give you any question. using company database. So all 10 questions, you just use the Microsoft Northwind, given in available in W3 schools. Oh, I can post the database script of Northwind, yeah, so that you can install on your own computer. Yeah. Later you will see there is a difference. So the version running on your own computer and the version running in W3 school, there is a difference. Okay, there is a difference. Some difference is quite important. W3 school, yeah, based on my knowledge last semester, they use the older version. Yeah. This semester, yeah, sometime later, I need to do some testing and see if they switch to newer version. The one we are using, when we download XAMPP, current version of XAMPP, then we run under MySQL current version. Current version, it's newer than the version on W3 schools. Yeah, because there is some important feature. The older version does not support. The newer version supports some important features. Yeah. So the version different. Yeah. Just let you know. Yeah. All right. Yeah. Then attribute concept. Yeah. Column, field. Yeah, I mentioned before attribute. So here the terminology. Yeah. So you can see for the same concept, there are several different ways to call the same concept. Yeah. Yeah. So I will explain the reason quickly. Yeah. Attribute, a column in a table or a field. Yeah. These two names. Yeah. So here, the difference, main difference is one set of names that people use in the business environment. Okay? Yeah, so here, let me point them out. Yeah. So the table, row, record, yeah, column, field, these names mainly used in the business business environment. Yeah. All right. Then these names, entity, attribute, the names, you know, pretty much in the academic environment. Okay? Academic environment. Because the SQL, the whole SQL language was developed as an academic project at the beginning. When they started this project, it was an academic project. So a lot of names they use, you know, formal names used in the academic environment. But when this project, you know, the business people started to use this SQL project, very important for the, you know, business world. So they adopt this project in the business world, but they don't like to use the many formal names they don't like to use. Okay? Hard to understand. Yeah. For the communication between business people, they want to use easy terms, straightforward terms. Yeah. So they use those set of terms. Yeah. All right. Many terms like these, you know, what you see here. Yeah. Represent some property of interest on an entity, such as employee names. Yeah. All right. Relation. Yeah. So then there is another. So other than entity, there is another important concept. It should be represented in business relation concept. Yeah, for that reason, second type of table should also be used. Yeah. Yeah. So let's look at the relation. Information in business. Yeah. All right. Relation, yeah. Also, we use a table to store the relation information. Relation between objects. Yeah. So what's the relation, right? What do you mean relation? Yeah. So after you define those tables for entities, entity objects, after you define those, then still some part of the information missing because those entity objects, there are some possible relationships among them. Yeah. So you also need to store the relation information. But relation information, that's quite different from entity type information. Completely different. So for that reason, the second type of table should be used in business. Yeah. All right. Here, actually, so here you can see these two concepts, entity and relation. These two concepts, that's a special way people use to describe the general world. Yeah. Yeah. So here we can talk about, in order to understand this concept well, I may like to refer to graph theory. Graph theory in algorithms, advanced algorithms. If you learn that graph theory, yeah. What's the definition of a graph? To define a graph, you need to have vertices, right? Yeah. Vertices represents objects in the real world, right? Vertices concept. Yeah. So to define vertex, okay? Yeah. But still not enough to represent the real world problem. Yeah. You also need to represent relationships among the vertices, right? Yeah. So how do we represent? Okay, yeah, good, yeah, no problem, yeah. So we also need to represent the relationships between two vertices. Yeah. So we use edge. Edge. Each edge represents one relationship between two of the vertices. Yeah. So you have many edges in your graph. Okay? Yeah. Yeah. Here you can see what we're doing here. Basically, similar way to describe the business world. We need to represent the business objects. We also need to represent the relationships, okay, between two entity objects. Yeah? Just like a graph theory. Okay? Same way. Yeah. All right. So then, let's understand the table types, these two types. Okay, all right. Entity type, yeah. Describe object in the minute world, like employee. We already talked about that. Then this relationship type. Yeah, let's try to understand a little more this relationship type. Yeah. A relationship among two or more entities represents an association among the entities. Yeah. Or mapping. Association or mapping. Yeah, the word. Yeah. Similar terms. Yeah. Remember, in our case study examples, we use the mapping, right? Remember, in our two case study, we create relationship table. Yeah, so in this relationship table, all right? The first column represents the first entity object. For example, keywords. Yeah. Yeah. The Google search engine, the first column, keywords. Keywords entity, right? Yeah, entity object, keyword. Second, web pages. Yeah. Web pages. But we use URL for web pages. Another entity object, right? Yeah. Each web page is an entity object. Okay. Then, when we do pre-processing, we need to establish the mapping, right? Yeah. So mapping, yeah. Association, right? Yeah. So we create a, relationship table. Each row represents one association, one mapping. Yeah. So each row of this relation table, yeah. So you have the ID of the first object, keyword object. Also, you have ID of second object. Then you create an association record. That record means one association, one relationship. Okay? One edge. If we use graph theory, one edge between them. Yeah? So that, you can see this second type of table also very useful. Okay? So in our 2 case studies, very useful. Yeah. All right. Yeah. Examples. Yeah. Yeah. So here give you another example, but this example is in our company database. Yeah. So company database. In this company database, there are 6 tables, total 6 tables. Yeah. Employee table, department table, project table, dependent table. Already 4. Okay. All right. Then there is the 5th one. These 4 all entity type. Okay. The 5th one also entity table, department location. Each department has a location. Okay, location table. Yeah. Department location table. So 5 entity table. But last one is a relationship table. The last one is called works on. Yeah. Works on table, relationship between employee object entity and the project entity. Yeah. The mapping. Yeah. Each employee works on several projects. So you need a mapping. Employee 1, mapping to object 3, 5, 7. Okay? Right? Yeah. Things like that. Okay? And each project, yeah, so here, there is another important relationship I want to talk about. In database design, this kind of information is useful. All right. Here, let's look at the two columns in this case. The first column, employee. The second column, project. Okay? Yeah. Employee, you have 1, 2, 3, right? Yeah. Project, you have ID 1, 2, 3, and so on. Okay? All right. Employee 1 may work on multiple projects, right? Okay? Yeah. Then each employee may work on some of the projects. Okay? All right. So that's you look at from the employee perspective. But you can also view from the project perspective. Each project may involve multiple employees, right? Each project may involve multiple projects, okay? So here you can see from employee, the first column, multiple employees to a project. From second column, multiple, So here, the relationship here, I'm talking about, people call it M to M. M, multiple, okay? The first column, okay? So multiple objects in the first column maps to one object in the second column. M to M. But the second one, multiple objects in the second column are mapped to one object in the first column. Okay? Two direction, both direction, multiple to one, multiple to one. Okay? So in the database design, people describe this kind of relationship called M to M relationship. Yeah. All right. Then, based on this understanding, you can see there are several other possibilities, right? Yeah. Because some relationship, it could be one-to-one. One-to-one, okay? Yeah. Each object in the first column is mapped to exactly one object in the second column, one-to-one. Yeah. Each one in the second is mapped to only one in the first column. So that's the one-to-one, okay, relationship. And the one-to-M. One-to-M, okay? Yeah? Yeah? So each object could map it to multiple objects in the second column, but the other side, each object in the second column, only one object in the first column is mapped to it. Yeah. So then there is another possibility, M to 1. Okay? M to 1. Yeah. So total four different types of relationship tables, yeah, based on the mapping types. Yeah, total 4 types. Yeah. Then in the database design, you need to specify, okay? Because currently, people use some special design tools, software tools, to draw the diagrams of the tables in the database. When you draw the relationship, you need to specify which of the 4 types. Okay? Yeah. So you select. Then people look at your table design. Oh, they understand the meaning. Yeah. All right. Yeah. A relation between here I'll give you another example. Relationship between a math problem and a category. Yeah. So here, math problem, category, think about 2 entity objects, also M to M. Why? Because each category contains many math problems. Yeah. Another direction also, each math problem could belong to multiple categories, right? Yeah, because one math problem containing the knowledge in different categories, algebra, geometry, trigonometry, right? Yeah, one problem could use knowledge from different areas. Yeah, so when you do characterization, you can assign it to multiple categories. So it's an M to M relationship. Yeah. All right. Yeah. Yeah. So here, I already explained that. Then next one, history of schema. Yeah. Because the meaning of the schema also evolves. Yeah. There are 2 main versions. Yeah. The first version, not very good, because at that time, people did not have a very good understanding of the, requirements in the SQL language. So at that time, the first version of schema, so what's that? Did not include the concept of So actually, the first version, there is no schema concept, or people. So if no schema concept, how to organize different databases? So they didn't organize. So they put all the tables that belong to different databases in the same place. That's the early version. So that means the tables from different databases are not separated, mixed in the same place. That's the early version, okay? Yeah, because no schema concept. Yeah. Definitely, so people quickly noticed the problem. Yeah. Messed up, very easy, for different databases, the table, which database this particular table belongs to. How to see it? Yeah. So then the second version, then people create this schema concept to organize the tables. So tables that belong to different databases should be put under their corresponding schemas. Yeah? So each schema represents one database. Yeah. So then under this database umbrella, so all the tables that belong to this database are organized separately in this schema. Yeah. Much more convenient to use. Yeah. Same schema. Yeah. So earlier, because no schema, so people just cheat. All the tables are put under the same schema. Yeah. Very messy. The early version. Then, starting from the SQL version 2, so group together tables and other constructs. Yeah. So everything that belongs to the same database must be put under the same schema. Yeah. So then, much better. So that version then is used as in our current version. Yeah. All right. So just history a little bit. Yeah. All right. Next, 8.2, database languages. Yeah. Because we needed a lot of things. So after the structure is established, constructs, all those things, then we need to work on the databases. To work on the database, how to work on the databases. So we need appropriate programming languages. Okay? We need appropriate languages to help us to manipulate databases. Yeah. So database languages, all right, several types, the languages. Yeah. Here, so let me just talk about the academic project. Yeah. Because these languages, they are designed in that academic project. Yeah. So in that project, one language, the researchers, typically researchers in academia, they created these languages. So the first one is called a data definition language, DDL. Yeah? When you define your data, you need appropriate languages. Okay? So they call that part DDL. Yeah? So that's one type of language. One. Yeah. Yeah. So this one. Needed. Yeah. Define schemas. Yeah. But there is another type of language should be used. view definition language. You need to view, after you define that, you need to see the format of your data clearly, so you need a special view language, right? So this VDL type of language also needed in the, in your project, in that project, okay? SQL project, yeah. Specify user views, yeah. How to make the user to see your data clearly, right? Yeah. Special view language needed. Yeah. Then another type called data manipulation language, DML. When you manipulate the data, yeah, so another type of language needed. Yeah. All right. So here you can see, the project pretty complicated. Yeah. So many things to do. Yeah. All right. Yeah. So currently people do queries, right? So that's the manipulation part. SQL queries. So that's the manipulation part. All right. So then, at the end, so they created the SQL language containing all these three types of language. Yeah. So they do not create three separate languages. It's just the one SQL language containing the roles of, so SQL can do all these three things. Yeah. Okay, all these three things. Yeah. Yeah. So, all right. Yeah. Yeah. You just know because sometimes, these three languages, many people actually, they do not need to know these languages. Okay? They just use SQL. Yeah. Every place, they just use SQL. So they don't care, DDL, DML, yeah, not important. Yeah. But after you have this background knowledge, sometimes you may read the technical articles, right? Yeah. Technical articles, some places, this kind of terms may appear. Okay, DML, DDL, So usually in the technical articles, these two languages may appear. Yeah. The view part rarely appear. Yeah. The definition, because people need to talk about the definition. Manipulation, people talk about manipulation. So those two terms are used. Yeah. View, So because people do not bother to use too much detail. Yeah. All right. Yeah. Yeah. So now we understand some background of the SQL. Yeah. 8.3, properties of SQL. So let's learn some properties. Yeah. The standard language for commercial relational DBMS. Yeah, standard. Yeah. So when I talk about the standard, so here I want to connect to what we learned before. Yeah. So I mentioned a little bit in our module 1 about the SQL standard. Yeah. And in our quiz 1, I gave you such question. So when we say standard, remember there were two parts in the SQL. Okay? Yeah, so here. The SQL, so your understanding of SQL should contain two parts. The first part is the core part. Second part, the extension part. The core part, that's the standard. When we talk about SQL standard, we refer to this core part. Yeah. Extension part, not in the standard, industry standard. Yeah. Because the extension part, different DBMS, they have their own ways to implement their own extension part, their own features. Yeah. They do not need to talk about other people. Yeah. So they feel, so in my product, I want to add these convenient features. Okay? So MySQL has a lot of its own convenient features. Yeah. Other DBMS, they do not agree. So we don't want these features. We want other convenient features. Yeah. So things like that happen frequently. Yeah. But that's what people call the extension part. Yeah. Yeah. And then that caused the problem. Because of this extension part, that caused the problem. When you convert your databases for one particular DBMS to the database for another, you need to do a lot of non-trivial work. The conversion work, actually, you need to do a lot of testing. So first you need to write a statement differently. Yeah. Yeah. Same thing, you need to use a different way to write SQL statement. Then you need to do testing, to make sure it works as expected. Yeah. So mainly for the extension part. Yeah. The problem is people do not know which part is the extension part, right? You can only do testing. Yeah. You can study the document. Yeah. Yeah. MySQL document, Oracle document. You study the document huge. Yeah. Big book. Yeah, you can search to narrow down. Yeah, but you need to study documents. Then, after you understand the syntax, then you need to do experiments, testing. Okay, make sure it works as expected. So that's why a lot of work, the conversion, from one database to another. A comprehensive database language. Yeah, this SQL. Both DDL and a DML containing. Yeah. Yeah. It has facilities for defining views on database. Yeah. Because the views, when you retrieve the data, you need to present your data in different ways. Okay? Yeah. So that's the view part. Yeah. Show your data in certain structure. So that's the view part. Okay? Yeah. All right. Specifying security and authorization. Yeah. Permission. Yeah. Yeah. You need to have some special ways to grant privileges, right? Privileges. Then authentication. Yeah. So when the users try to use the DBMS, you need to check the authorization, right? Yeah. If the users has the correct account information, right? Yeah. So DBMS contains, all those features. Yeah. Defining integrity constraints. Yeah. Yeah. So we learned some integrity constraints. Yeah. So uniqueness constraint, right? Yeah. Data type constraint. Yeah. Later primary key constraint. Yeah. So all those integrity, foreign key, right? We also learned foreign key constraint. Those integrity constraint. Yeah. So you can define. Yeah. Specifying transaction controls. Then SQL has its own way to, define, to manage transactions. Yeah. I mentioned that in our transaction topic. Yeah. I mentioned that how to define transactions. Yeah. Rollback, beginning of the transaction, right? Then you a list of SQL statements you put in that transaction. Then you commit. Yeah. At the end, you commit that transaction. Yeah. After that, you need to define the rollback function. So if something is wrong, you want to roll back to the beginning of the transaction, recover. So you stop doing anything in this transaction. So roll back to the beginning point and rewind. Yeah. Do not do any operations in your transaction. Yeah. So all those things in your DBMS, so you need to find a way to do it. Yeah. Yeah. And in Java follows the structure. Yeah. Java, you can do transactions in Java language. In Java, so you need to use certain Java classes to define a transaction in this structure, exactly this structure. Yeah. All right. Rules for embedding SQL statements into a general purpose programming language. Just, yeah. Yeah. So then SQL, yeah. So here, so this line, very important, yeah, for the application point of view. People need to use SQL statements in programming languages for applications. Yeah. Yeah. Then, yeah, so regarding the rules for embedding, yeah. So you need to embed SQL statements into general purpose programming languages. Yeah. For this question, I like to expand it a little bit. Yeah. Expand the sentence. How to do it, right? So you may wonder, yeah, so although you know this, yeah, some rules, yeah, but how to do it? Yeah. Here, I may like to compare Java way and the PHP way. Yeah, because they are different. So two different ways to do the SQL statement embedding. Yeah. Java way, SQL. Yeah. PHP way, straightforward. Yeah. Let me explain PHP way first. Yeah. Because much easier to understand PHP way. Yeah. Straightforward way. All right. So for PHP way, for each DBMS a set of functions are used. Okay? Yeah. That's straightforward, right? For example, for MySQL, then you need to use a set of functions only for MySQL DBMS. You cannot use, if you change to Oracle, you need to change to a different set of functions. Yeah, that's natural, right? Yeah. For any DBMS, when you use a different DBMS, PHP, the creator, PHP, yeah, because people in charge of PHP, they need to develop a new set of functions working for a new DBMS. Okay? Yeah. So that's the PHP way. Java using different way. Okay? The Java way. Java way more efficient. Okay? Java way more efficient. Yeah. Java way use a set of interfaces. Oh, sorry. Yeah. Interfaces. for programmers. Okay, so this interfaces, common interfaces, okay, covering all DBMSs. Oh, sorry. Yeah, covering all DBMSs. Yeah, what's that? When you change to different DBMS, you do not change these interfaces. Okay, same interfaces. All right. Yeah, yeah, yeah. In Java, you know the interface concept, right? Interface concept. Interface concept. Abstract class. But interfaces only contains a list of methods. Yeah. List of methods, okay? Yeah, interfaces. Yeah. 4 interfaces are used. Yeah. All right. When you switch from MySQL to Oracle, you do not switch interfaces. You still use the same interfaces. Okay? More efficient. But you have to change something, right? Yeah? You have to change something. Yeah. Yeah. Otherwise, how can you make the switch? Yeah. So Java way, making switch to different, yeah. Let me use the space here. Yeah. The part of change. You need to change something. Okay? Yeah. So let me talk about part of changes. Yeah. Yeah. This part, no change, this part. Okay? This part, no change. No change for different DBMS. Okay? Yeah. So you know the meaning. Yeah. Yeah. All right. All right. Yeah. Let me list one by one. Okay. The first thing you need to make the change, there is a concept called database drivers. You need to change database drivers. What's database drivers? Library. Okay? Library. Yeah. Database drivers containing another set of interfaces for DB vendors. Yeah. So what's included in the drivers? So another set of interfaces for DB drivers, DB vendors. Yeah. Okay. Yeah. For communication. Okay. Yeah. The interfaces. But other interfaces, definitely they need to write a lot of implementation classes. Okay. Everything needed for the DB communication must be included in one library class. Yeah. So Java JAR, Java archive file, JAR file, .jar file, one library file. So you download from the vendor's website. Okay. MySQL website, you can download Java driver. Okay. MySQL driver. Yeah. Oracle driver, you can download. All right. Oracle website, you can download the driver file, one library file. Oracle.jar. Okay. Yeah. So one driver's file. All right. With driver's file, then you can do the communication. Java do communication with the DBMS through drivers class. Okay? Drivers class. All right. So you need to change the drivers. Second, yeah, account information, right? Yeah. Username, password, and URL. Okay? Yeah? So that information. Yeah. So user account info plus URL. URLs, because DBMS running on database servers, right? URL for DBMS. DBMS running on database servers, how to reach those database servers? URL, through appropriate URLs. So you need to change URLs, okay? Yeah. So user account information, username, password, account information. All right. 3, some of the SQL statements you need to change, right? Yeah, as I mentioned before. Yeah, they use different extension part. Yeah. Core part you do not need to change. Yeah. Some of the SQL statements. Okay? Yeah. You need to make the change. Yeah. But the Java classes, Java method, you do not change. Okay? Yeah. Java classes, yeah. All right. So you keep there. Yeah. Because that's common. The Java class methods common for all DBMS. Okay? Yeah. And the SQL statements, when you use the SQL statement, they are treated as parameters, right? As string parameters, yeah? Because SQL statements are passed to methods as string parameters. Yeah? So what do you change? You change the parameters. Okay? You do not change class name, method name, no change. As string parameters. Okay, see? Yeah. So that's the Java way, all right? That's the Java way, yeah. Now you can see Java way more efficient, yeah. Easier to use than the PHP way. Yeah. PHP way, if suddenly some new DBMS comes out, then they need to get their programmers, yeah. You need to develop a new set of functions for this new DBMS. Java, it's not. Java make the responsibility to vendors. If a new DBMS comes out, its vendor has the responsibility to provide drivers. So Java team, they only need to give them the interface part. Vendors interface, that interface. So Java, so you use my interfaces. But those vendors need to implement these interfaces using their own way. Okay, so they're responsible to write their own Java classes to do communications using the interfaces given by the Java team. Okay, after they developed, yeah, because they're familiar with their own product, right? Yeah, they do not need to communicate with other people. Yeah, PHP. Those PHP, how do I say that? Yeah. PHP people, they're not familiar with a new DBMS, right? They need to do communication with a new vendor, and they need to implement new functions. Yeah. So here, Java different. Okay. So your product, yeah, I only give you abstract interfaces. Okay? Yeah. So it's public. So everyone can download my interfaces easily. Okay? But you need to implement all the methods specified in the interfaces using your own way. Okay? Because you know how to do communications. Yeah. With your own product. Yeah. So after they develop, they just upload the drivers class. So then the whole community Java community. They just download the vendor's drivers library class. Then you can use it. Yeah. So here you can see these two different ways. Yeah. All right. Yeah. Yeah. So because this is important, so I spent a lot of time to talk about this, communication way. All right. Structure, of SQL core. Yeah. So some part of I already talked about it. The core specification. Yeah. So this part we call the industry standard. Yeah. Then specialized extension part. Yeah. So I already explained. Yeah. In optional modules. Yeah. So the vendors, they can add their own features in this part. Yeah. All right. The consequence. Yeah. In application programs, when you change DBMS, you may need to change your SQL statements. So that work usually not easy. Okay? Yeah. Especially for a big project. Yeah. So that kind of work usually very time consuming. Okay? Yeah. So it's a big thing. Yeah. Yeah. All right. Yeah. Yeah. So that's the So I'm pretty much Oh, there is another. Yeah, but I do not have much time left. I have just one slide left. Compare these SQL terms. Yeah. But let me leave this slide to next class. Yeah, because I need at least 10 minutes to explain this slide. Yeah. Some concepts, pretty important. Yeah. I need 10 minutes. Yeah. So before part B, let me finish this slide first. So then we start part B. Okay. All right. Yeah. That's it.